Is there a shortcut? Can I simply use the same rule for every variable? Once again, I'm asking you, is there a shortcut
sir.
for data cleaning? Every variable is unique, isn't it? So what is left over? Have we looked at all the variables? Have we explored all the variables?
Yes, sir.
Yes.
Pura ka pura. What is
In
left?
credit
We
utilization
have
and debt to income ratio.
explored the categorical and discrete variables. How did we explore categorical and discrete variables? Using
By
which
looking
technique?
at the frequency.
By looking at the frequency distribution. Are you with me, everyone? Step one, tell me, even before this, what did we do? Even before this, what is the first step? We looked at the basic
Data,
contents.
Data.
Basic,
Metadata.
yeah. Metadata. We have looked at the basic contents and the metadata. Then we looked at the categorical discrete. Tell me the next step.
So analyze the continuous variable.
Continuous variables. Can we create frequency tables for continuous variables? Is that a good idea?
No, sir.
Continuous variable, by meaning itself, it means that it takes too many values. Already we have seen for age, it is not giving a meaningful result here, isn't it? Continuous variables take too many values. It will be difficult for us to create the frequency chart. How do you explore the continuous variable from its minimum value to its maximum value? I want to
The
see
box plot.
absolutely everything crystal clearly. I want to see. Then what should I do for exploring continuous variables? There are two options.
Box plot.
I can
Percentile and
look at the
distribution.
box
Box
plot,
plot.
and then if I
Percentile
wanted to
distribution.
see
Percentile.
exactly clearly complete drill down also I want to do, then I can do the
Percentile.
Percentile distribution.
percentile distribution. This is the best way of doing it. This is the alternative option. Even histogram also will give you a good idea. Okay, but these two will give you perfect answers. So what are the continuous variables? So this using box plots or histograms for visualization. What does the box plot tell you quickly? Tell me once again, recheck. What does the box plot tell you?
So the number of
Compressed. The box is
Whether
compressed.
the outliers present or not. Okay. If you want to really know what percent of the outliers are there, you have to see the percentiles. So here is the approach. You look at the box plot. You will get to know whether there are any outliers or no outliers. If there are outliers, what would you do? You look at the percentile distribution and find out exactly what percent of the data is clean, what percent are outliers. Do you know exactly how to drill down and find out what percent are clean, what percent are outliers, all of you? Do you know drilling down and finding out what percent are clean, what percent are outliers?
Yes, sir.
Yeah, we have already seen that. So first, let us go to these variables. Monthly utilization percentage. We have anyway done a clear detailed analysis on that in the previous session. So monthly utilization, once again do it. Tell me what percent of the data is clean, what percent of the data has issues, what percent of the data is clean, what percent of the data has issues. What are the limits of monthly utilization percentage? It should be anywhere between
100%.
0 to
Zero
1. Anything beyond 1 would be a erroneous value. So tell me, in monthly utilization, what are the issues? So if you draw the box plot, monthly utilization,
Box plot is not.
histogram also not coming, box plot is also not coming. Clearly, it is very clear that it is having outliers for sure. Why the box plot? Like, how do you interpret this? Tell me, all of you. How do you interpret this?
0 to 25%.
Huge outliers.
There are huge outliers.
25%.
Yeah. So how much of the data is clean? Anything?
80%.
Then 97%
80% is clean.
Nice.
How about 90? 90% is also clean, no? Check this out. 90,
Yeah.
91,
97%.
97.5.
97.5. We can say 97 roughly. And then it is 3%
3%.
issues. I'm not going very deep into this because we have seen this. You yourself have told me earlier, you have done this exercise and told me that 97% of the data is clean, 3% of the data has issues. Any question on this? Anybody? Strictly speaking, it is 97.5, 2.5, but anyway, that's not a big deal. We don't need to go for that much granularity. Are you clear on this revolving utilization, which is simply known as monthly utilization? Why am I saying 97% clean, 3% issues? Absolutely clear? Okay.
So the histogram,
Histogram?
that is me. Like what we can
I
analyze.
ignore this histogram. If you're not understanding, simply ignore this one. Okay.
Okay.
Yeah. Because anyway, we got the point that is required, isn't it? Yeah. What is the point that we are looking for? Are there any issues in the data or not? Okay. So in the data, there are 3% issues. That's what we need to get. Okay.
Sir, the issue is with only 3%, but
Right.
the box plot is showing too much compressed. Is it?
Too much compressed. The reason is it's not the percentage. The box plot on the y-axis, you have these numbers. Since the number is very high, 50,000 is very, very far away from the rest of the values. All the values are where? Here only. Yes or no? But some values are going this far. That is the reason.
Okay.
If it would have been like the outlier would have been 0.1 or something or 1.2 or something, then box would have appeared. Since it is far, far away, that's why the box plot is coming like this. Okay. Even if the issue is less than 1% also, but if the maximum value is this far, the same result will come. Okay. Because the outlier is far away. That's why box is compressed like that. It means very, very far away outlier or very higher outlier. All right. Let's wait here and take a couple of questions. Then the other variable is monthly income. Already some of you told me what is the issue with monthly income. Kya tha? We made a
Sir,
note
null
of it.
values.
Missing value.
Null values. You have 1,50,000 records. 1 or 2 records are null, we can ignore them. Can you tell me the count of records that are null out of 1,50,000? How many records?
29,731.
Is that true? All of you check that out.
Yes, sir.
Are you telling me roughly 30,000 records are null?
Yes.
Are you telling me 30K out of 150K, which is like 20%? Are you telling me every fifth record is missing?
Yes.
20% are missing values. Is that a serious
20%.
issue or it's okay?
The serious issue.
Serious issue.
That is a serious issue. 20% missing, every fifth record is missing. Like that, apart from one variable, looks like every variable has issue. What is the only variable that did not give us any issues? Only dependents, isn't it?
Dependent.
Sir,
Apart from that, every variable has issue. Is that what happens in real life or all the variables will be clean?
It actually happens.
It actually happens. That's how the data is. That's why I told you in the real life machine learning projects, data cleaning is given a lot of preference. That's why even when you're attending machine learning interviews, there will be a lot of questions on the data cleaning part because you will be doing a lot of data cleaning there. First of all, to clean the data, you need to identify the issues. Once again, I'm asking you the question. How do you identify the issues if the variable is categorical or discrete? How do you
sir,
explore
by
the data?
frequency distribution.
By frequency distribution. If the variable is continuous, how do you explore the data?
The box plot or
Box
percentage.
plot.
Either
or
box
percentile.
plot or percentile. How do you interpret the box plot? How do you identify outliers from the box plot?
The more it is compressed, the more outliers are there.
The box is compressed either upper side or lower side, then there are outliers for sure. Okay. These are some of the interview questions that will be asked. Now, some variables, they contain outliers. Have you observed them already? Outliers. Some variables have default values 96, 98, 96, 98, 96, 98. Are they coming everywhere?
Yes, sir.
Yes. Instead of keeping 0 or some value, they are keeping 96, 98. Sometimes you have some codes. 96 means DC is the disconnected card or something like that. Some variables have missing values. Have you observed any missing values in any of the variable?
Yes, sir. Monthly.
Yes, sir.
So utilization percentage, monthly utilization percentage has 3% outliers. 1 month late frequency has 96 and 98. Monthly income has 20% missing values. ठीक है यार, 97% is clean, 3% only outliers. Can I keep the outliers and go ahead? Is that a good idea?
No.
It's 3% outliers, right? 97% is clean, right? Can't I just go ahead? 3%
sir.
क्या ही impact करेगा? Can we think like that? Not really.
Correct, sir.
Do you think this 3% of the data is sufficient to turn the whole analysis upside down?
Yes.
Yes, sir.
Yes,
Sometimes
sir.
we end up giving loans to the bad customers and rejecting all the good customers applications.
Yes.
Outliers pull, they will impact the whole analysis. Yes or no?
Yes, sir.
So keeping the outliers is not a good idea. Do you agree with that statement? Keeping the outliers in the data, no matter how small percentage they are, it's not a good idea.
Yes, sir.
Yes, sir.
Let us see what happens if we delete the outliers. Let's say in income, I found around 20% issues. I deleted them, outliers or missing values or whatever. In some other variable, utilization, remember, deleting. Deleting means, am I deleting only from one column or I have to delete the whole row?
Sir, the whole
Whole
row
row,
will be.
sir.
Can you have a data set where column 1 has 1000 records, column 2 has 900 records, column 3 has 950 records? Does it happen that way? Delete means what?
No, sir.
That means you have valuable data here.
Observations.
Do you have valuable data here?
Yes, sir.
Yes.
Are you going to keep them or are you going to delete them? Because there are missing here.
Okay.
Think about it. Are we going to lose that valuable data information if we delete them?
Yes.
Are you with me? Deleting means deleting the whole row. 20% of the income was missing. That's why you deleted the whole row. In utilization, another 3%, like 20% issues here. In utilization, 3% issues here. Only in utilization. Their monthly income was available, valuable. Are we going to have that information or going to lose that information if I delete? Lose that information. Now monthly income 20% issues, number of loans around 3% issues, utilization 3%. If I like every variable has issues, yes or no? Because
Yes.
every variable has issues. If I keep on deleting, do you think that's a good idea, or am I going to lose a lot of information?
Sir,
We lose a lot of
information.
Do we get the data for free or do we buy the data from bureaus?
We buy that.
Data from bureaus.
We buy the data from bureaus. Is it a good idea to buy the data and delete all the data like this?
No, sir.
So can you delete the data like this? Deleting, is that a good option?
No, sir.
Not a good option.
No.
Not at all. Keeping, is that a good option?
No, sir.
No.
Cleaning is a good option.
You cannot delete the data. You cannot keep the data. What can you do? Well, let us see. What you can do is, depending on the magnitude of the errors, you have to take the right precautions. You take a variable. All of you listen to this carefully. You take a variable. If the errors are less than 10%, you follow one path. If the errors are more than 50%, let us say you have a data set. In that data set, more than 50% are missing or outliers. For example, you have income, only 30% values are available, the remaining 70% are missing. What will you do? Is it a good idea to take the average of this 30%, fill this whole thing with that average and go ahead with analysis? Is that a good idea? Tell me honestly, what do you think?
No, sir.
No, sir.
Do you think this 30% is a representation of the population, or is it a biased sample which is telling us about only one certain population? It doesn't really represent the whole population. What do you think?
Yes,
So it's a biased
One
information.
percentage of population.
It does not represent the full population. It's not a good idea to simply calculate the average and fill it with all these things. Yes, we should
Yes, sir.
not
Yes,
do
sir.
that, isn't it? Never ever do that. If the percentage of missing, if the percentage of outliers is more than 50%, drop the column. What do? Drop the column. It is more dangerous to use it than dropping it. Do you understand the danger of using it? You may be getting
Yes, sir.
erroneous results, isn't it? Drop the column. If you want to get anything out of it, max to max, if you want to get some purchase out of it, you want to get some information, what you can do is you can create an indicator column. It is a flag variable or indicator variable. Income underscore flag, income underscore indicator variable. It takes values zeros and ones. Everywhere when income is missing, it will take 0. Income is present here. What will be the value that will take?
1.
Now this variable is indicating whether a person has declared income or whether a person has not declared income. Is it right information for person 1 0, person 2 0, person this person is 1, this person is 1? Maybe you can use this variable instead of this variable. Income underscore indicator flag variable. Maybe people who all have declared income, there is a lower bad rate, lower default ratio. People who did not declare income, there is a higher bad ratio. Can that be captured by using that variable? Can we do the slicing and dicing? Can we do the target variable analysis by using that flag variable?
Yes, sir.
Yes, sir.
Yeah. But is it a good idea to do it with original income variable? What is the average income
No,
of the
sir.
people and all that? Are you with me? So my
Yes, sir.
suggestion is, if more than 50% of the data is having issues, first drop the original variable. You cannot use it. Why? It's not giving you the true representation of the underlying population. It is giving you a biased opinion. Is it ideal to take biased opinion and build the model on it?
No, sir.
Not at all. So max to max, if you want to take something out of it, what can you do?
Create a flag variable.
Flag variable or an indicator variable. What are the values taken by that indicator variable?
0 and 1.
0
Zero
or
one.
1. If it is missing, 0. Otherwise 1. So instead of using this variable, which variable will you use in the model?
Flag variable.
Flag variable or indicator. Is it right to use this variable? Is the information
Yes,
in
sir.
this accurate? Tell me.
Yes,
Yes,
sir.
sir. Yes.
0 indicates no income declaration. 1 indicates income declared. Is that right information? Are we cooking it up? Is that right information?
Right information.
Yeah.
Yes, sir. Right.
If there is any pattern in this, model will capture that. Are you convinced logically, business wise, when we do this? All of you?
Yes.
Yes, sir.
This is one of the standard that we have to follow. But I think more than 50% missing, if we are buying the data from bureaus, we don't accept that, isn't it? We will go back and fight with them. Yes or no? But that is very rare scenario. What about the scenario that we got here? In some scenario, 97% clean. Okay. In one of the scenario, 97% clean, 3% issues. In some other scenario, 91% clean, 9% issues. Most of the data is available. Most of the data is available to me, but a portion of the data is missing. Now tell me, sometimes this data is outlier data. Sometimes this data is missing value data. Sometimes this data is default value data. ठीक है यार, 97% clean. The remaining 3% is issue. Can I keep it as it is? Keeping is
No,
not a good
sir.
option. No. Can
No,
I
sir.
drop it?
No,
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 sir.
sir.
Neither keeping, not dropping. Give me a suggestion then. What can I do with this 3% of the data?
The average.
Sir, we can find
Indicative.
dispersions.
More than 90% of the data is clean with you. Yes or no?
Yes, sir.
Yes,
You're
yes,
perfectly
sir.
confident on that data. 3% of the data has issues. Less than 10% of the data has issues. What can you do? You can replace this with
Condition.
Average.
Average values.
average. There are two averages. What are they?
Mean and median.
Mean,
Mean, median.
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 Out of these two averages, which one is safer to replace that with?
Median.
Median safe होगा ना? Yes or no? So that 3% issues or less than 10% issues, you can replace them with mean or median, or generally median is preferred. This is known as imputation or standalone imputation. Depending on this variable, rest of the values, you are imputing, substituting the missing or average, missing or default or outliers with the average, especially median value. If you remember, one of our variable was monthly utilization. What was the issue with monthly utilization? 97% of it was clean. Remaining 3% of it has issues. 97% of it clean. In fact, 97.5 was clean. Remaining all has issues. Now here is the process that I'm following to clean this variable. First, I'm finding the median utilization. Is this formula clear? Median utilization part?
Yes,
Nothing
sir.
difficult in that. Now let me clean this variable. Monthly utilization. What I'll do is, it's not a good idea to overwrite the original variable. This variable has issues. Don't overwrite it. Create a new variable. Monthly utilization new equal to, take monthly utilization variable as it is. Can you tell me what this step will do? What this will do?
Copy.
Sir,
It will
replace.
simply
It's a copy.
replace कर देगा.
No, no. It's a new.
Let's make a copy.
It will make a copy of monthly utilization and keep it in monthly utilization new. Now what I'll do, I'll try to do a filter on this. I'll go to monthly utilization new. Wherever that monthly utilization or monthly utilization new, any of them, wherever it is greater than 1, how much percentage of that will be greater than 1?
2.5.
2.5%. Replace them with, what should I keep there? So basically go to monthly utilization new and access all the locations where it is greater than 1. Please replace that with
Median value.
what should I keep here? Median utilization.
Utilize.
Now execute this. What is the cleaned version? Now you will get a warning like this, but anyway the process will happen. So what is the old variable? Monthly utilization. What is the cleaned version of that variable that we should be using for the further analysis? Which variable
Monthly
will you?
utilization new.
Monthly utilization new. If the client is asking you what was the issue, can you show me the old variable? Do you have it?
Yes.
Yeah. Now, what is the variable that you're going to use for further analysis? Monthly utilization new. Usually, it's not a good idea to replace the variable. Otherwise, we will be missing the traces, isn't it? So at the end, we are going to use only monthly utilization new. That is the cleaned version. You can also check monthly utilization new, the percentiles. It will
Yes.
not be any issue now. Yes or no? Because monthly utilization new, we have anyway cleaned it. Check this out. Maximum value is 1 now. Where is that 2.5% gone? Where did we
Yes.
push it? From there we have taken, we put it at, we replaced it with median, which means we have pushed it at
0.15.
0.5 or 0.15 is what we have kept. Have you understood this code once again? All
Yes,
of
sir.
you? Yeah. Very straightforward. First create a copy, access only those locations where monthly utilization is greater than 1, replace them with median utilization. Got it? Quickly do this, write these 2 lines of code and check whether you are getting the code correctly. You will get a warning like this because we are only replacing only few values, but with that warning also it will work. It's not an error, just a warning. Right? Now, Focus back, all of you. Come back here. Come back here. There are some categorical variables. For example, you have a variable called region. It takes values east, west, north, south. 95% of the times it is available. But 5% of the times it is taking either missing or NA. If more than 90% of the data is available, less than 10% of the data has issues, what do we generally do? Imputation. Find the average and replace. अब इसका average कैसे find out करेंगे? What is the average of east, west, north, south?
Northeast, north, south.
अरे ऐसा कौन डिफाइन किया? ठीक है, what is the average of all those four? There is nothing like that, isn't it? East, west, north, south, you cannot find the average value.
Frequency, you can go for the frequency.
So there is a better idea. In this case, instead of convert east to 1 to 2 to 3 to 4, if we convert like that, what happens? Which one is higher, east or south? If I give you this data in your original data, which one is higher, east or south?
South.
क्यों?
No,
Why
no.
south is higher? कौन
No
बताया ऐसा? कौन है ये लोग? Who told that south is higher than east? There is no such ordering, isn't it?
All are same, sir.
All are same. But when you convert, one will be less than 4. Yes or no? So are we really converting the data as it is, or are we creating a bias in the data? Are we creating erroneous data when we convert it into
That's
numerical?
erroneous data.
Yes,
You are creating erroneous data. Are we supposed to create erroneous data like that?
No, sir.
No, we cannot
Let's check.
put from our side and create erroneous data like that. No. So here is the idea. What you can do is you can always look at the target variable. You can impute based on the target variable. For example, you have the sales. Let's say sales is your target. In region East, the sales was around $1,800. In region West, the sales was $5,000. In North, the sales was $2,400. In South, the sales was $3,000. See, region is missing. Is sales also missing in those regions? In the places, region was missing. Sales was available. Sales is a different column altogether. That is available. If I look at these data points and their average sales, that is coming out to be $4,800. East, West, North, South, you have the average sales. In the places where you have missing, that also you have average sales. Now, if I had to replace this, I know I have to replace it with either East or West or North or South. Which is the most reasonable replacement of these missing values?
West.
West.
Why West only? Why not East, North, South? Why did you discard them? Because
Highest.
Sales is pretty much close.
the population where the sales is very much close is this one. I would say logically, can you give a real logic to your client? If your client asks you, why did you replace with West? Can you give a good reason for it? Yeah. You will say that in this place also the average sales is this. That means there's a high chance that they are from West. Are you with me?
Yes, sir.
That's what you call imputation based on the target. But here the target is continuous sales. But in our case, the target, sometimes the target is 0 or 1, buying or not buying, customer buying or not buying. Let us suppose in East, only 20% are buying, 80% are not buying. In West, only 10% are buying, 90% are not buying. Generally, people who buy are less only, isn't it? In North, 40% are buying, 60% are not buying. In South, 90% are buying, 10% are not buying. And in this list of rows, the percent of people who are buying are 9%. The percent of people who are not buying are 91%. What is the most reasonable substitution for this out of East, West, North, South? And I can confidently say they must be
West.
from that region.
So
West.
West,
West.
West. Why is West? Why not any other region?
sir, because it is close to the.
Close to this.
So here, the people who are buying percentage or buying rate is very much close to this. So if you look at our data, the number of times 30 to 59 days past due, that means 1 month late frequency. 1 month late frequency, values that it can take. What are the values that it can take? It is known as 30
0,
TPD. It can be 0, 1, 2, 3, max to max
0,
24. Okay. But what are the values that it is taking? It is also taking values like
96 and
96 and
96, 98.
98. Now what we will do, what is our target variable? Is it continuous sales or is it discrete 0 or 1? What is the target
Discrete.
variable? What is our target? Try to think about it.
So
We are
discrete.
trying to predict. What are you trying to predict here? Customer will eventually be
Category.
Default.
Default or non-default?
defaulter or non-defaulter. Yes or no? So what is our target then? Is it discrete or continuous?
Sir, discrete.
Discrete, it will be 0 or 1, or categorical or discrete. We can say anything. Like if you're considering yes versus no, categorical, yes means 1, no means 0, then discrete. Okay. Now what we will do is, this is seriously delinquent. If seriously delinquent, look at this, seriously delinquent. If seriously delinquent is 0, what does that mean? Customer is good customer or bad customer? Seriously
The bad
delinquent.
customer.
Seriously delinquent is 0. 0 means no, or so this means no. This means yes. So customer is no, not seriously delinquent, which means what?
Good.
Is a good
So
customer.
1.
If a seriously delinquency, 1 means yes, that
Bad.
means bad customer. Seriously delinquency is nothing but bad. Okay. Now usually good rate is high or bad rate is high generally.
So good rate.
Good rate will be generally high. Now you will create a cross tab like this. After creating this cross tab, what you will do is you will look at the individual percentage 0, 1, 2, 3, 4, 5, 6 and so on, and then 96, 98 also you'll see. Let's say good rate here is 90%, 98%, bad rate here is 2%. Good rate here is 96%, bad rate is 4%. Good rate in this bucket is, let's say, 90%, bad rate is 10%. Here good rate is 88%, bad rate is 12%. In this one, good rate is around 90 or around 60%, bad rate is 40%. Even in 98, good rate is, let's say, 58%, bad rate is around 42%. If this is the case, if I have to replace 98 with one number, what will be that number?
So 5.
The reason being,
It is close to
it is
the
close
good.
to that one, isn't it? The same logic that we have used earlier. So what we are going to do when you have a target variable which is discrete, and if you have a categorical or discrete variable which cannot be found as an average, then in that case you create a cross tab. So code wise, how does that happen? Let us see. First, look at the frequency table for the 1 month late frequency. 98 is there, 96 is also there. Then you try to create a cross tab. In the cross tab, you will get the numbers. Cross tab is directly, you can use pd.cross tab, mention the first variable, mention the second variable. That will give you the number of zeros and number of ones. But are we going to look at the numbers or the percentages? Are we going to look at the numbers or the
Sir,
percentages?
percentages will be more accurate.
Percentage of 0, percentage of 1s, that will be more accurate. So how do you calculate percentages? We use a function called dot apply lambda x. Until here it is syntax. You just write this table dot apply lambda x. Okay. So what it will do is it will go through each and every row, whatever function that you write, like x here represents one row for you. And whatever function that you write here, that will be applied on each and every row. So you simply write x divided by x dot sum. That means in this row, what it has to do, it has to take this one divided by sum of these two values. This one divided by sum of these two. This one divided by sum of these two. That's what this cross tab is going to do. Cross tab percentage. There is one more way of doing it as well. There are multiple ways of doing the same thing. This is one of the way. Now what we need to do is we have to go through this table. I know 96 is wrong, 98 is wrong. Especially I'll be focusing on 98. Tell me why. Very specifically, I'm focusing on 98. 96, I'll do whatever
Because
I
there
do.
are huge frequency of customers.
So is it fair to say I'll just focus on 98? Whatever I do with 98, I'll just replace the 96 also with the same treatment. I'll not really pay a lot of attention on 96. Why? Is that
Sir,
fair?
because it has low.
It has
Less
only
cumulative
hardly 5
validity.
records. There's no point in banging our head over it, isn't it? So 98 is the one that I'm serious about it. Now tell me, what should I replace 98 with? What is that 98 which is matching to? Is it like 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7? Whichever is it matching, let me know. What is it matching with?
Sir, 6.
Nearest one. Nearest one. If not exactly match, at least the nearest one. Which one is that? Everybody come up with your own answer.
Sir, 6.
98.
Yes, 98 is matching with which one? Like you can compare the bad rate. See
Sir,
the nearest
6-1.
bad rate. What is the
Five.
bad rate of 98? 98 का bad rate कितना है? What is the bad rate of 98?
42%.
42%. Are you all on the same page? Come here. Bad rate of 98. Bad rate of 98 is 54%, no?
Yes, sir, 0.54.
54%, yes or no? Here it is 42. In our actual one is 54%. Now, is there any other bucket where exactly or nearby 54 by which is the nearest
Sir,
bucket?
6.
Which is the
0.53.
nearest bucket which is having 54% bad rate?
6.
6. Is it fair to say 6 also has around 53% bad rate? Is it fair to say if 98 is not permissible, in its place, I can substitute it with
6.
6? Are you convinced with that logic, all of you?
Yes, sir.
Why am I doing that? First of all, 98 is not allowed. I cannot delete, I cannot keep. I have to replace it with the most reasonable, most logical substitution. I would say I would look at the bad rate or good rate, and it is matching very near to this one. And what I'm going to say, whatever I do with, yeah, until 13, everything is fine, isn't it? 0, 1, 2, 3, and so on. So look at my treatment. What am I doing? Are we going to replace the original variable?
No, sir.
No. So this is what I'm going to do. The code is create a new variable. Then after that, what is the next piece of code that I'm going to write? In this new variable, I will write the syntax if that variable is going beyond 13, if it is going beyond 13, why am I writing 13? From where I'm picking this number 13? Tell me.
From the previous one.
Here until 13, everything is fine, right? Only 96 or 98 are coming. So whatever I do with 96, I'll do the same thing with 98. Both of them are same. So whenever it is more than 13, I'm going to replace them with what? Replace them with
6.
6. So this new variable, can you trust it now? Can you look at the frequency of that one? What is the frequency? Value underscore counts. What is the maximum max it can take?
So 13.
13. Is there any value beyond that? Nothing.
No, sir.
Are you convinced with this type of cleaning, especially for categorical variables? Because
sir.
average cannot be found there. So those are the two scenarios. There's a third scenario, which is tricky scenario. One scenario is percentage of missing is less than 10%. What do you do in that scenario?
Imputation.
You do the
Impute.
imputation. Within imputations also, there are two types. If the variable is continuous, then what will you do?
The standalone imputation, the average.
Standalone imputation by using average. If the variable is categorical, if the variable is discrete, then what will you do?
Sir, we'll compare and take the closest value.
We will compare the bad rate and compare the closest category that it can be replaced with. Are you absolutely clear on this? Have you understood the logic behind them?
Yes, sir.
Yes, sir.
Yeah? No doubts in that. Yeah. That is one scenario. If the percentage of missing or the percentage of outliers or the percentage of issues are more than 50%, then what will you do?
Sir, we'll drop the column and create a flag variable.
Max to max, you can create a flag variable. Flag variable takes how many values?
0 and
Two
1.
values.
0 and 1.
0 and 1. 0
One.
means
One.
0 means
One
it is
means,
missing. 1
Six.
means available.
Very-
Now, some scenarios are tricky. Sometimes you have 20% issues. 80% of the data is clean. Or 25% issues, 75% of the data is clean. Tell me one thing. 25% is a big chunk. Is it a good idea to drop the whole column and make it into 0 and 1?
No,
No.
sir.
I think we are going to lose a lot of information, isn't it? Valuable information. Can we do this treatment to this scenario?
No, sir.
No, sir.
We
No.
cannot. That's not a good idea. Tell me one thing. 75% is available. I agree. All this is available. 25% is missing. Is it a good idea to calculate the average and replace this whole 25% of the data with the average of the 75% of the data?
No, sir.
That is also not 100% convincing, no? Yes or no? 25% of the data is a significant chunk. Do you think if you do this imputation, give it to a data scientist, will he ever get to know that we have replaced a lot of data with the average value?
Yes, sir.
How does he get to know?
Metadata.
Metadata में क्या मिलेगा? We have already given this cleaned version. Somehow we have to carry forward this information that a significant chunk was missing. Yes, you will do imputation. I agree. Here, 3% missing, 97% clean. There is no need to carry forward. But here I feel that somehow we need to tell the next data scientist that a significant portion was missing. We have replaced it. Do you agree with that?
Yes, sir.
Somehow I have a feeling that this 25% or 20%, whatever it is, because the missing is more than 10%. When you have this tricky situation, you have to do two steps. You have to create two variables. Tell me what are the two variables? First version is cleaned version of the variable. What is the second variable that will create?
Uncleaned.
You will also keep the flag variable.
Flag variable.
What is this cleaned version doing? It is simply replacing the original variable values. What is the use of flag variable? What are we carrying forward?
Same values.
We are also telling the model that a significant portion of this data was missing. For example, in our monthly income variable, if you take, what was the issue with monthly income variable?
The missing value.
This is the monthly income. 80% of the data was clean. 20% of the data was missing. In this case, you will be creating two variables. The first variable would be, what would be the first variable?
Sir, the new variable.
So monthly income new, which will have all the monthly income, and this 20% missing, what are we going to fill that with?
Median.
Median. So that will anyway clean it. We can use it for analysis. But
Yes.
somehow we need to tell the model that, you know what? When we were doing this data cleaning, we found that there is a significant portion of the monthly income missing. Maybe that may carry some important information. So that is why we need to create another variable. What is it?
Flag variable.
Flag variable. What are the values does it take?
Zero,
0
one.
and 1.
0,
Zero.
0, 0, 0, or I think this is 1, 1, 1, 1. Here it will take 0, 0, 0. Are you carrying both the information that there is a significant portion that is missing, and you're also keeping that variable? Is it fair to do this like this? Think about it.
Yes, sir.
Why am I doing this special treatment? Tell me, why am I doing like this? Is one of the interview question. Why are you
To keep
doing
all
this
the
special
variables.
treatment of
To keep
flag
all the
variable? Yes, why can't you simply replace it with median and leave it?
So that we can categorize
Because
them.
it may
Keep
misguide
all the
the
variables.
other data
Because
scientists.
here there is a significant information that is missing, isn't it? 20% is significant. I cannot simply replace it. That's why I want to carry forward this. Maybe I will use this variable as well as this variable in the model building. If there is a pattern, then the machine learning model will capture it. So when you have data which is more than 10%, less than 50% issues, what do? You do both the steps. What do you mean by both the steps? First, you will be creating one variable, which is monthly income indicator. How do you create this indicator? Check this out. Have you understood this code? First, create monthly income indicator, fill it with 1. Then I go to the same variable. Wherever monthly income is null, fill it with 0. So when you do value counts, how much percent will be 1? How much percent will be 0? Tell me in this example.
Sir,
80%
80% will be 1
0.
and 20% will be 0.
20% will be
Exactly 20% will be 0. Where are you doing that condition? Where is that condition? If monthly income is null. 3 lines of code. Is this clear? These 3 lines of code.
Yes, sir.
Yeah. Is this the only step that we are going to do with monthly income? Are we going
No,
to
sir.
just no? What is the second step?
Imputation.
imputation.
Monthly income new.
Replace
Wherever monthly income is null, replace that with what?
Medium values.
median value.
These 2 pieces of code. Are you clear on this?
Yes.
Yeah. That's what we do. Once again, a quick recap. There are 3 distinct scenarios you will get. Less than 10% issue,
10%.
10 to
10
50%
to
issue,
50%.
more than 50%
Greater than
issue.
More
Let's
than
start
50%.
from here. More than 50% issue.
We'll
Straight
drop and
forward.
create a
Creation of flag
Flag.
Drop
variable.
the column and create a
Drop
flag.
the column. Create a
Flag
flag.
variable.
Flag variable.
Convinced with the logic?
Yes.
Yes, sir.
Because more than 50% is missing IR, I cannot really trust your data. Don't ask me to take your values. Yes or no?
Yes, sir.
Less than 10% issue, more than 90 is clean. In that case, what will you do?
Imputation.
There are 2 types of variables. One is continuous variable. Then you will do
Standalone imputation. The mean
imputation.
median.
What if I have a categorical variable? I can't find mean median. Then
Take the closest value to the category.
Median.
first you need to compare it, create a cross step with the target. Yes or no?
Very good.
Target variable, and then take the closest category. If it is between 10 to 50,
Sir, we have
not
to do
very high,
both.
not
Right?
very low.
Both the process.
You
Do
have to
both.
do
That
the
means do the
flag.
imputation as well as
Create a
Flag.
flag
that
variable.
means from
Flag.
one variable you will be creating 2 new variables. One is a clean version, one is a flag variable version. These are just examples of 3 variables. Yes or no? Do you think
Sir.
you can just automate this process, or you have to go through each and every variable, identify the issues one by one?
So
Every
we
variable
can
is
alternate.
we can automate to an extent, but every variable will have very, very new issues, isn't it? So depth ratio, again, you will have an issue. You have to do the imputation similar to that one. Number of open credits and lines and loans. Again, you have to like every variable, whatever variable we have found, definitely it will fall in these 3 categories. Based on that, you have to do the either imputation or flag variable or both. Data cleaning process, to understand it, it's not very difficult. But to do it, it requires a lot of patience and you have to spend a lot of time on it. Do you also agree with that point?
Yes.
Data cleaning process, the time that it takes is proportional to the number of variables that you have. Do you agree with that point as well?
Yes.
If you
Yes.
have too many variables, then you have too many issues that you need to solve. Data cleaning process will take even more time, especially for the countries or for the places, for the portfolios where the data is collected freshly or newly, isn't it? First time if we are collecting the data, then it will take hell lot of time. Okay. So data cleaning process, when you're doing it, you have to have very high patience. In fact, the projects that you're going to receive, obviously your data will have issues and you will be going through each and every variable, and definitely it will fall into these only. So I have given you this list. Based on these only, you're going to do the data cleaning process for every variable, for every variable.